vLLM software comes with built-in benchmarks. This is how benchmark command looks. vLLM bench serve, latency, throughput. I will focus only on serve. This is what I plan to benchmark. On Nvidia H100 and H200, I will benchmark larger model like Qwen 3 coder with 30 billion parameters. On Nvidia RTX 4090, A100, H100 and H200, I will compare performance on smaller models like Gemma, Llama, Mistral and Qwen 2.5. And as a bonus, just recently released from OpenAI GPT OSS 120 billion parameters model, I will test it on Nvidia H100. Note here, Gemma, Llama and Mistral models require to accept license and access token from Hugging Face. For those three models, I will install Hugging Face CLI and I will log in with token what can be created on Hugging Face. There are different deployment methods. I will only compare tensor parallelism and data parallelism. Command line option -TP and -DP or full version of those options. I will also benchmark mix of those options. For example, tensor parallel size 2, data parallel size 2 will start model on 4 GPUs. I will have server where I will run model and I will have client. Client can be local, the same machine, or remote. And on a server, I will start model. And on a client, I will start benchmark command with 10,000 prompts and 1,000 concurrent connections. Main vLLM server for benchmarks will be with Rocky Linux 9.6. It will have 8 GPUs H100 with 80 GB VRAM. And this IP address I will use for benchmark command to connect to a server. This is important environment variable, torch CUDA arc list. It should be set before starting vLLM server. Depending what GPU card you have, I will use these architectures 8.0, 8.9 and 9.0. And for example, I can use command export torch CUDA arc list equal 9.0 for H200 and H100. Full list of architectures can be found on this web page. This is my server. This will be my remote client. First, I will install Python 3.12 because module which I will install later, Flash Infer, has issue with default Python 3.9 on Rocky Linux 9.6. I will create dedicated user for vLLM, change user and create Python virtual environment for vLLM. I have installed CUDA version 12.9. CUDA version is needed for next command link. One note here, Flash Infer Python is not critical component, but it improves performance. And as I mentioned, for smaller model Gemma, Llama and Mistral, it's needed to accept license on Hugging Face, so I'm installing client. I log in with token, I created it on Hugging Face. And as example, I will start vLLM on 2 GPUs with tensor parallel size 2. First, I will export torch CUDA arc list because I have H100 cards here. And with this command, I'm starting vLLM. This is model name, Qwen 3 coder, tensor parallel 2. It will start on port 8001. This is max model length. This is benchmark client. I will use remote server. It is possible to run locally. It also has Rocky Linux 9.6. I will install vLLM in Python virtual environment as it was done on vLLM server. Benchmark command will be the same, 10,000 prompts and 1,000 concurrent connections. This is how benchmark output looks. I will use these 3 lines as benchmark results: total token throughput, time to first token and inter-token latency. It was a lot of commands. I will add a link to a text version of this video with commands and results in the video description. This is Qwen 3 coder result on H100 cards. I benchmarked from 1 to 8 cards with different combination of tensor parallel and data parallel. So what makes sense is to run on 2 GPUs with Tensor parallel. It gives significant performance boost. When I benchmarked Qwen 3 coder on H200 cards, it performed much better on single GPU, but it was not scaling performance when I was increasing Tensor parallel or data parallel. As a bonus, I benchmarked model from OpenAI, just released, GPT OSS 120 billion parameters, and this is results from H100. I think I need to make some conclusions. H200 was the best in my benchmarks. For some reason, with Qwen 3 coder does not scale great. So run your own benchmarks. Different LLMs give different performance on different GPUs. Bye!